Whether we're talking about the deepest parts of our own minds or the surface of other worlds, humanity has always been defined by this relentless push into the unknown. We're explorers. It's just in our DNA. So today, we're diving into what's next, the next great frontiers, the huge challenges, and the absolutely incredible opportunities that are going to shape our future. All right, so here's the game plan. We'll kick things off by setting the stage for this next great leap. Then, we're going to journey through four really distinct frontiers: the inner world of the brain, the outer reaches of space, the very nature of intelligence itself, and then the wild new materials that can make it all happen. And finally, we'll tie it all together and see how it's all part of one grand project. So, what is it that powers this constant drive? Honestly, it's a fundamental part of who we are, isn't it? It's that desire to see what's over the next hill, to understand the universe that's ticking away inside our own minds, and to build the amazing tools that are going to take us to all these new places. And this quote from NASA, it just nails the mindset. It's not just about space, you see. It's about building on what we know piece by piece, using one frontier to unlock the next. It's the perfect bridge from what we achieved in the last century to what we're aiming for in this one. Okay, let's jump to our first frontier. And this might be the most personal of them all. We're talking about that 3-pound universe sitting right inside our skulls. We are right on the verge of directly connecting the human brain to our technology. And this right here, this gets to the absolute core of brain-computer interfaces. On one hand, the promise is just staggering. I mean, imagine restoring movement and communication for people with disabilities. But on the other hand, the peril is just as real. The risk that our most private thoughts could be hacked, or even that our actions could be controlled by someone else. So what is a BCI really? Well, at its heart, it's a direct line of communication between your brain and an outside device. It literally reads your neural signals, your intentions, and translates them into commands a computer can understand. The crazy part? It completely bypasses your nerves and muscles. Which, of course, brings us to the massive ethical questions. This table breaks it down really well. How do we keep brain data private? Well, with super strong encryption and by making it anonymous. How do we make sure people really know what they're signing up for? Through crystal clear consent forms and constant communication. And who actually owns your brain data? The policies have to put you, the user, first. And maybe most importantly, how do we make sure this doesn't just benefit the wealthy? By focusing on making it affordable and accessible. And it all just boils down to this one huge question, doesn't it? When a company can read your mind, who owns that data? Is it you? Is it the company? This isn't science fiction anymore, folks. This is a question we have to answer, and we have to answer it soon. Okay, let's shift gears. From the microscopic world of the neuron, we're going to zoom all the way out to the endless black of space. Our second frontier is about going back to the moon, not just to visit this time, but to stay. And that is the Artemis program. NASA has this great line for it. They call this the Artemis generation. And I love that because it reframes this whole thing. It's not something our grandparents did way back when. No, this is happening right now. It's for us. It's an invitation for all of us to be part of that next giant leap. So how are we actually gonna pull this off? It's basically a 4-step plan. First, you launch on the Space Launch System rocket, which is the most powerful rocket on the planet. Second, you travel in the Orion spacecraft. Third, you dock at the Gateway. Think of it like a small space station orbiting the moon. That's our base camp. And finally, astronauts will use a special human landing system to get down to the surface. But why go back? Well, there are 3 big reasons. First, for the science. There are so many secrets locked away on the moon. Second, for the economy. This could kickstart brand new industries, a whole lunar economy. And third, for inspiration. To show a whole new generation that we can do incredible things when we team up. This isn't just about flags and footprints anymore. It's about building a permanent home away from home. All right, on to our third frontier. This one's a little more conceptual, but it is just as important. Before we can really perfect artificial intelligence, or even truly understand our own brains, we first have to figure out the fundamental rules of what intelligence actually is. And that's where this field called embodied cognitive science comes in. It's asking a huge question. Are there common rules that control agency? The ability to act with purpose. whether you're a single cell, an ant colony, or a human society. It's kind of like trying to write the universal owner's manual for intelligence. And this question right here is exactly why this matters so much. If we want to build truly smart systems, better AI, more natural BCIs, you name it, we can't just throw more computing power at the problem. We need a much deeper, more foundational understanding of how thinking and acting actually work in the first place. Which leads us perfectly into our final frontier, the actual physical tools that are going to power this future. Because to make any of this stuff a reality, from super advanced AI to light-speed communication, we need brand new kinds of materials. So for decades, our computers have all run on electricity. But we're starting to hit the physical limits of what we can do with it. The future? It's probably in light-based computing, what's called photonics. It promises to be way, way faster and use a lot less energy. There's just one big problem. We need a way to guide light signals on a tiny chip without them bouncing all over the place and losing power. And enter the gyromorph. This is a totally new class of material, and it sounds like something that shouldn't even exist. Up close, it's messy and disorganized like a liquid, but from a distance, it has the long-range, repeating patterns of a perfect crystal. It's both at the same time. So why is that a big deal? Well, what this crazy structure does is what's important. It creates something called an isotropic band gap. The best way to think about it is like a perfect microscopic highway for light. It basically puts up walls on all sides, forcing the light signal to go exactly where you want it to with zero interference. No traffic jams. This could be a total game changer for building computers that run on light. So, we've gone on quite a journey, right? We've gone through the human brain, all the way to the moon, into the very nature of intelligence, and down to the atomic structure of brand new materials. Let's pull all of these threads together. As we've seen, our path forward is really being forged on 4 key frontiers at the same time. We're exploring our minds, we're exploring the cosmos, we're exploring what it even means to be intelligent, and we're creating the stuff to make it all work. And this is really the most important thing to take away from all of this. These aren't separate races happening in different labs. A breakthrough in a material like a gyromorph could power the AI that helps us navigate on Mars. A deeper understanding of intelligence could help us design a BCI that feels like a natural part of our own body. They're all connected. They are pillars of one single incredible project. And so that leaves us with this. We are developing powers that are almost godlike. The power to travel to other planets, to merge our minds with machines, to engineer matter from the ground up. The ultimate question, the real final frontier, is one of wisdom. With all this power, what kind of future are we going to choose to build?